This video will be about the 2008 OGT, and it's from problem 6 through 10. Problem 6 states the graph shows the total sales per year for the X300 and X400 speakers produced by an audio manufacturing company. Then it gives us the actual graph showing the empty dots for the X400 and the filled in for the X300 over all the years up to 2002. Then it says the manufacturer plans to discontinue the X300 speaker when the total sales for the X400 speaker are greater than the total sales for X300. Based on the trend in the graph, what is the earliest year that the sales of the X400 speaker will be greater than the sales of the X300 speaker? So on this problem, we're going to have to continue the pattern for each of these. Or we could try and just do an actual line. Here I have the tools where I could just lay a line down and make it go through all the points. That might be a little harder if you're doing it by hand. So to follow along the points, we look for the pattern. So we're starting here at 10, and then we go a little above 10, halfway in between 10 and 12, so about 11. A little above 11, and then almost to 12, and then finally this dot gets to 12. So that's starting the pattern over again. So this point and this point are basically where it starts kind of repeating itself. So the next point went a little bit up, and we have that one here a little bit up. Then we're about halfway. So the next one's about halfway. So then the next point was a little above halfway. And the one after was almost to the next line. And then we hit the next line. And then a little above, about halfway, a little bit above halfway, almost there. And then we hit an actual crosshair on the graph. So now for the X400, we have to figure out the X400's pattern. So here we start at 2, and then we're almost to 4. We're almost all the way up to the next line. Then we're above the next line, almost to the middle, and then we hit another crosshair. So that's where our pattern starts over again. So we go almost to the next line, halfway, hit a crosshair. So almost to the next line, halfway, hit a crosshair. Almost to the next line, halfway, hit a crosshair. So you can see we want this X400 to be above it. Where they meet is this year here. We can go down to the year and say, well, they're going to be the exact set of sales. The X400 will sell the same amount as the X300 at the year 2005. So notice that's not on our answer choice. We have 2000, 2003, 2006, 2009, because they didn't say equal, they said greater. So 2006 is the first year where we go greater than the X300 sales. Next question. Michael paid $6 for a ticket to a football game. Soft drinks at the game cost 75 cents. Michael bought X drinks at the game. Which equation represents the total amount Y he spent? So he starts by spending $6. So we want it to start with a 6. And he just bought the one ticket. So it's just the number 6 itself. That eliminates B because B has the 6x. A has the parentheses with the x, and the x would be distributed into both. That parentheses are saying x affects both things, but the 6 is not affected by the x because the soft drinks are what's associated with the x. Soft drinks, there were x drinks. So the 0.75 and the x should go together. Since he's spending more money, we're adding it to the amount he's already spending. He spent $6 and now he's spending more money, so our answer choice is D. Problem 8. One style of jacket comes in 3 sizes: small, medium, or large. So 3 sizes, that's an important part. These jackets have either buttons or a zipper. So it doesn't list it here, but that means there's 2 options here. The jackets are available in 5 different colors. So there's 5 colors to choose from. How many different combinations of this jacket are available? So to figure out all the combinations, when they say the combinations, they're saying you could pick a small jacket with buttons and maybe it's red. Let's say one of the colors is red. But you could pick a small jacket with a zipper that's red. So it's saying all the different combinations you could do with those options. To figure that out, we just multiply the numbers together. 3 sizes, 2 options for the closures, the buttons or the zipper, and 5 colors. 3 times 2 times 5. You can do that by hand, or it never hurts to check with your calculator. That gives us 30. Problem 9 is a geometry problem. ED, so that's the actual line. You start at E, go to D, that's that entire side. And AB, that's down here, that entire side, are both perpendicular to BD. So when it says the word perpendicular, that means they meet at a right angle. BD hits this at a 90-degree angle, and it hits the bottom, AB, at a 90-degree angle. In triangle ABC, the length of AC is 4, and the length of AB is 2. So they labeled that triangle. If the length of EC is 8, what is the length of ED? So a problem like this is called a similarity problem, and we can set up a proportion. There's also word problems where we have to set up proportions, but this one's our geometry where we set up a proportion. So what we do is we want to keep it organized. There's a lot of different ways to organize this. I usually do triangle by triangle. I'm going to have one side be the small triangle, and one side be the big triangle. So on the small triangle, they gave us 4 and gave us 2. So I'm going to put 4 over 2. So 4 is called the hypotenuse. It's not touching that right angle, it's across from it. So I did hypotenuse over that 2, which seems like the smallest side on the triangle, the one I highlighted in blue. So on the big triangle, now we have to keep it in the same order. We have to put the hypotenuse over the smallest side. If we don't put it in that same order, our proportion will not be correct. So the hypotenuse is labeled with 8. The smallest side, which I also highlighted in blue, the E to D, is not labeled, and that's where we need our variable. We need to figure out what that side is. So I'm going to call it the variable x. Once you've set up your proportion, you cross multiply. So the x is going to come up and multiply by the 4, and when you multiply that, it's just 4 times x. You can't multiply a number times a letter and get a new number, it's just the number times the letter. Then we do 2 times 8 on the other side. We did the bottom left up to the top right. That's why it's called cross multiply, because we're going across and up. So 4 times x equals 16. And now we do opposite operations. When you're working with an equation, you want to get rid of the number 4, and the 4 is multiplying by the x, so the opposite is to divide. But what we do on one side to cancel it out, we have to do on the other side. So now we do that division. 16 divided by 4 is 4. So our answer choice is A, 4 centimeters. So one more problem, problem 10. When x is greater than 1, which expression has a value less than x? On a problem like this, I prefer to pick an actual number. It's hard when there's a variable, so we're going to not use a variable. So if x is bigger than 1, I can pick any number bigger than 1. I could pick 500. That's bigger than 1. Usually it's best to pick something small. I'm going to pick 2. So if x equals 2, and we picked that because 2 is bigger than 1, now we can try each answer choice and see if it fits which has a value less than x. We're looking for a number less than 2 when we plug x in. So everywhere we see the variable, we're going to replace it with a 2 because we picked it. We picked a random number that was bigger than 1. You could pick any number, 3, 4, 5, as long as it fits the requirement as bigger than 1. So answer choice A says 2.5x squared. We're going to replace the x squared and replace the x with a 2, with the number we picked. Anytime there's an exponent, it's helpful to put parentheses around the number you're replacing. Makes it a little easier to plug into the calculator. So I'm going to clear this all out first, and we do 2.5 parenthesis 2 and parenthesis squared. It gives us the answer on the other side of 10. So 10 is bigger than 2, and we wanted a value less than the 2 we picked. It's got to be less than x, and we picked x is 2. So A is not our answer. So now we do B. Now it's kind of hard to see, but that's x cubed to the 4th. So answer choice B is x cubed, sorry, not x cubed to the 4th, x cubed plus 4. So we replace the x with a 2 again, and our goal is still to have this number that we get right here come out to be less than 2. So we do parenthesis 2. Raising it to the 3rd power, we've got to use this AB button and then hit the 3 to show it's to the 3rd power. And then we click to the right and put our plus 4, which gives us 12. Our goal is to be less than 2. We're still bigger than 2. That does not work. Now we try the next one. Let's try C. So there was B, there was A. Let's try C. Square root of 2 minus 2. So again, we need to use the calculator. We do square root 2. We have to click outside the square root. If I click minus 2 right now, it's going to stay under that square root bar. We want to click to the right so that we're outside the square root and now hit minus 2. Now we get negative 0.585. 786, it keeps going. So we say, is that less than x? If x is 2, is this less than 2? And it is. So this is our answer choice. Sometimes you can also figure these out with kind of a logical process. It said we wanted a value less than x, so less than is the important part here. If you multiply and square something, those all make numbers bigger. Same thing with B. We cubed something and added, those make with positives at least, it makes all those numbers bigger. C, when you square root a number, it gets smaller, and when you subtract, it gets smaller. So C is a good logical choice just because it's making the numbers smaller, and we wanted less than. D is kind of a mix. It makes a number smaller. Square root makes a number smaller, but then you're adding, and adding makes numbers bigger. So since C, everything is getting smaller, it's the most likely option. So that covers problems 6 through 10.